see how this is working. Yeah, that's good. Okay. So let's see. I'm going to do a quick test on YouTube. I can check the audio myself by doing this. And then give me a second. This will tell me what's happening. How are we doing? How are we doing? Good. We're getting audio there. Yeah. And is it working here? Are we getting audio? Yes, it should. Nice. Okay. That gives me audio there. And then these guys should be working just fine. Okay. Yeah. Okay. That's good. All right. Okay. And that's good. Okay. Nice. Okay. So we're all, and then in terms of the presets over here, how are we doing? So we can fly over there. Nice. And we'll see that. Excellent. And it's coming. And YouTube is, because we had a crash this morning, but we're okay. So we'll come back here. Everything's flying nicely. Okay, just hold on a second, and then we're going to begin in a couple of minutes. There's my little eyeball. I just want to bring up something here. Geez, nobody in the cosmos right now. Very interesting. That's a good sign. We got people in person. But let's bring up Carl Sagan for a second here. And why don't you bring up your questions when we're having the class? Because it's it's so, I got so much to do here. But we'll talk, okay? Make sure you bring it up. Thanks. Okay. Uh, okay. Okay. Why this is really slow today? This is so slow. There we go. Good. 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 So let's run this. There we go. Great. Okay. Oh, you can leave it there. We'll get to it in a minute. Yes. Hold on, let's just go back and just start a bit. We won't run the whole thing. Let's stop there. Well, everything is working essentially the way it should in this room, because what you should feel when you enter this space is a bit like you've entered a television show, a studio, but it's a classroom, it's a lounge, it's a theater, it's live on YouTube, it's with young people who are here to interact, and we're learning about the world. This is a new multimedia classroom experience for humanity. And maybe one day this thing will get some traction and we will make some history. All I can tell you is I'm having a blast inventing this with all of you and trying to make this really work. So, we actually have something quite remarkable today in this room. There's nobody in the cosmos. Oh, I see now just one person. Hold on. Let's make sure. Here comes Kieran Deep. Let's make sure Kieran Deep can hear clearly. Hello, Kieran Deep. Can you hear me clearly at the podium? Just put a yes in the live chat if you can. Okay? Go ahead. Can you hear nice and clear? Yeah. And that means that I can move away from the podium now. The headset's working. It means these things are going to be working better. So we're going to have podcast level FM radio audio. If you hold things close to your mouth, like karaoke, and then we have an amazing recording that you can watch as long as you want. And this is a classroom. So, welcome everyone to Humanity's Destiny. And what we're going to do today in our actually, there are only 3 classes left this semester, is we're going to continue with space exploration. And we're going to drill down a little bit more on what we know and what we don't. But our visionary is this gentleman. He was the voice on the video that you just saw. I can play it again for all of you, but if I get this working well with all the different media, I'm going to be like the DJ up here at the podium with all sorts of videos, images, text, stuff flying in and out, but mostly with you guys sitting in this nucleus and talking about everything. But that means that we have a bit of a struggle because we're going to have to put the fishing rod out to the corner over there and bring these 4 in. But they could at least they're looking. They're looking. No, it's okay. You can come in anytime. Okay, just I got their eyeballs for some reason today. They're and and some of these guys are handing in assignments early, by the way, and they're looking. Well, I haven't looked at them, but I'm sure they will be pretty good. Harris has handed something in. I think I saw Masoom put something in. So that really is exciting for me to see people getting things in early for that 10% bonus. Now, let me just remind you before we begin officially what that 10% bonus means, because it has come up. It's not that if your mark is 70%, you get 80%, or 80%, you get 90%. It means if you get 14 out of 20, you get 1.4 added to your mark. If you get 15 out of 20, you get 1.5 added to your mark, and then I round that off to 2. So it's 10% of the mark, okay? Which kind of works out to what you were hoping, I think, which is you're looking for that 10%. It's 10% of the mark, all right? And I hope that continues to encourage you to get things in early. But if you feel just a little bit deflated now because it's not quite what you thought, then still try to get it in early. Then I won't have to be up at 3 a.m. with a massive load of assignments to grade too late. So, yes, space exploration, we are going to start in a moment. But first, does anybody have anything they'd like to bring to the class's attention? Anything on their minds about humanity's destiny as of today, which is Wednesday, November the 26th, 2025. You are the generation, not me, that's going into the future. I'm in my, I'm looking at old age. I'm 62. I'm going to be 63 in December. So I'm starting to look at the, not the end, but you guys are, it's wide open, sort of. Nothing? Nothing super dramatic? Okay. Okay. Oh, here comes Ibrahim. Yeah. Okay. So here's the microphone. We'll get that going soon with all of you. But that's great to see everybody on board. Things are working technically, more or less. And so we will do a little review in a moment. But space exploration, the second part. We need to first understand something about space and what is space. What is our solar system? And then what I will do is now that I've got things kind of nicely teed up, look at that, just a click away, and I'm over to the notes from last week. I've got two different browsers going now. And so these are the notes from last week we can review. There were questions. I think these were Hamza's notes. Hamza, are these your notes from last week? Who took these? These look good? Yeah, way to go. Okay, thanks. And we've got some questions that we wanted to explore together. Exoplanets, warp drive, terraforming, and other things that are happening, as we say, off the planet. I need to get a scribe going for our very good notes. One day these GC notes will be, really people will come and want to see who did those great GC notes that week. One day, they'll want to see your notes, as we're going to make this class famous sometime. So, Kiki, you want to do the notes again? Go for it. Okay, there goes 5 out of 5. Yeah, she's going to do it. And if any of you want to help her, you can, but I think she's probably got it in hand. But if you need any help, let us know, and then that person will get 5 out of 5 too for doing notes. Great. So, should we jump into this? You ready to start going further into space and understanding something? Well, then why don't we start with our first really big note today to make sure that everybody is clear about the cosmic mindset. Let's really open our minds to this idea of light speed. Light speed. I would like to ask you a question just to start the class. And you have to answer this from your memory. You can't go to your machine to give you this information. Okay? So for the moment, you have to disengage from your machine. I'm not asking you to put your machine away. Just give me your humanness. The machine is a cold thing. The human is warm with blood. So what is light speed? How fast is it? How fast is the speed of light? Let's see if anybody knows off the top of their head. A photon of light. How fast is that going? Well, here we go. Noah, number 1. Here we go. Yeah, I'll help you out, okay? Yeah, Go ahead.
So I don't exactly have the exact number in my head, but off general knowledge of the name, it is how fast
How
light
fast? A photon. It's the
goes.
fastest thing in the universe. As far as we know, Albert Einstein helped us to see that back in the beginning of the 20th century. He confirm that for us. So, what is the speed of light? How many kilometers per hour or even per second does it go? Okay, Kiki? 1 point, not quite. Yeah, go ahead. You can hold on to a mic today too. Okay, great. So here comes Noah number 2. We can always tap into his brain. He's the speed of light, Noah number 1. What is it per second? How many kilometers per second does a photon of light go? Oh, it's the fastest thing. It is so dizzyingly fast that it's going to make your heart beat faster and your stomach might be queasy if you can get your mind. 250,000 kilometers per second. So let's figure this. And we're going to give Kiki the privileged task of writing how many zeros that is. So let's get this figured out for a second, because what we're doing right now today is we're stretching our minds to cosmic sort of that mindset, the horizon where you're opening yourself up to bigger things, faster things, stronger things. Because when you go into space, everything actually changes in terms of what the human is used to. And you and I probably will never have that experience by going onto a spaceship or rocket ship in our lifetimes. But many humans are doing that now. And they've been doing it since the 1960s in large numbers, what are called astronauts or cosmonauts. So we can, even if we can't go into space, we can still understand the mindset a little bit more. Well, the first thing is to open yourself to this idea of speed at this scale. 250,000 kilometers per second. Let's just get a kind of a sense of this and see if I can stick handle. Yeah, I'm going to really stick handle today. I'm going to do my cards and everything going. That's the planet. The planet, as you go around it, is 40,000 kilometers. Okay, that's the circumference of the planet. 40,000 kilometers all the way around. The equatorial circumference. You go around the middle, 40,000. So, if the speed of light goes 250,000 kilometers per second, how many times does it go around the planet in 1 second? Yes. More than 5. 6, 7 maybe? Can you, for the moment, just stop and think for a moment? This is real, but it's not, because you can't see photons of light moving, but they're all out there. The Bible begins with light and darkness. Light is the most basic thing on the planet, and it comes from the sun, and the photons are coming and streaming down here, and they're moving. So 6 to 7 times around planet Earth in 1 second. And Albert Einstein, who helped us understand that in the early 1900s, do you know what he imagined when he was about your age or younger? Do you know what he was dreaming about then? What would it be like to ride on 1 photon of light? What would it be like to buckle himself up like he's getting onto a horse or some kind of creature, and he's going the speed of light around the planet? This is the reality of space. It's dizzying, it's huge, and it's psychologically challenging for humans on planet Earth to understand. but it's real. And any astronaut will tell you, like Chris Hadfield, the Canadian astronaut who spent 6 months living on the International Space Station, a Canadian. All of you know probably who Chris Hadfield is. I'm sure you've seen him. We have a very active space program in Canada. Very active. As a matter of fact, in the new year in 2026, Jeremy Hansen, a Canadian astronaut, will be among the 4 who will be on the NASA mission called Artemis. And that mission will be going around the moon. And humans will be returning to the moon in 2026. Not on the moon, around the moon. They will be orbiting. And one of the astronauts, one of the 4, is a Canadian, Jeremy Hansen. So Canada's done a lot. We had a big arm on the International Space Station that would reach out into space to do engineering and projects. So Chris Hadfield is somebody that probably we will be referring to a lot today. But most importantly, it's this person right here. I want to bring him back. Whoops. And that is Carl Sagan, because he's a real big visionary for today's class. But let me just stop for a second and make sure that you've all just had a moment to think about this idea of light speed and what it means. And what I'd like to be able to do today as we go deeper in understanding what are humans starting to do in space, I'm going to take a more positive view of space exploration today. And I'm going to take the view that going into space is a good thing for us. But last week we began to talk about the other side, which is maybe we don't really need to be going into space so much. I might have to just close this just because I can see on the, yeah. But here, let me do this. I see it on the recording, but I can see it back here, and then the recording will be all washed out as well. So I'll just bring the blinds down. Is it? Yeah, no, they're coming down, okay? And usually this, it'll start to feel a bit darker and more quiet, kind of like those internet cafes used to be way back when I would go into one, but they're all closed down now. But they'd be these dark places where people would be sitting in front of their computers, and some guys would be at their computers for 72 hours, and some of them might even have diapers on because they were so addicted to the video game they couldn't get away from the computer. I hope none of you have had to put a diaper on when you're really into your video games. Try to at least. Yes, you get into it, you just. Okay, sorry. Ibrahim, did I see a hand go up? Is it 300,000? Even okay. It is definitely, because I stand corrected. Thought it was 250,000. Well, yeah. So who's saying it's three? Well, I'll take your word for it because I may be a little bit off with that. So that is even more dizzying. So that means it takes basically 7 times around the planet in 1 second, right? It would go. So let's first talk about this gentleman. And for those of you who weren't here at the beginning, I'm going to just play this little video one more time in case you haven't seen it. It's a lovely video, but it's just the tip of the iceberg in terms of Carl Sagan and his view of the cosmos. I'm going to tell you in a moment about a television series, a groundbreaking series he did in the 1970s called Cosmos. And it was one of the first attempts by a scientist to popularize the idea of astronomy. And you may know the name Neil deGrasse Tyson. Carl Sagan taught at Neil deGrasse Tyson's university, Cornell University. And I suspect Neil deGrasse Tyson has even talked about Carl Sagan. I'm sure he has. Yes? Microphone. Oh, take the mic so we can hear you. Sorry. Here comes some insight. Okay. So, have any of you watched the Neil deGrasse Tyson version of Cosmos? Well,
have.
go ahead, Kiki.
In Neil deGrasse Tyson's version of Cosmos, he actually discusses the moment when he first met Carl Sagan. He was a teenager living in the Bronx, and he had just gotten into a very good science program at that university, and actually Carl Sagan ended up uh, just making sure that Neil deGrasse Tyson got home okay because he lived in the Bronx.
It's a great little moment. Yeah, that's
So clearly they
not
have
surprising.
a close relationship.
Yeah. Well, he's one of the originals. He's one of the original visionaries who tried to bring this idea of understanding the cosmos to everybody, not just to the scholars or academic world or scientists. And he did it with a groundbreaking television series called Cosmos. And then many people have, over the years, taken parts of his television series or his talks and did little videos of them. And one of them is called Pale Blue Dot, that I'm going to show you again. Somebody online took his, I'm pretty sure it was from Cosmos, but it may have been from something else he had done, where he talks about this idea of looking back on the Earth from very far in space is looking at a pale blue dot. That's all we are. We're just a pale blue dot in the infinity of space. And that actually was based on fact, because he had worked at NASA for many years as a consultant. And NASA at that time had just recently photographed Earth from that distance, from one of their probes or satellites, and we could see. But Noah, go ahead. You might have some more information. Yes. The Voyager probes. Yeah. Can you write that down, Voyager probe? Because this is going to be part of today's class. What I want to help you to understand today, as much as possible, is the solar system, our solar system. And I want to be able to help you to understand that the reality of space exploration now is happening in our solar system, whether it's, probes that are telling us about Mercury or Venus. Those are the two planets closest to the sun. Of course, there's Earth. There's a mission to Mars planned. Elon Musk and Jeff Bezos are now competing. Jeff Bezos is Amazon, and Elon Musk and Richard Branson. You have all these large international entrepreneurs and global who also have their own space companies and rocket ships, and they are all now trying to compete for the person who's going to be able to commercialize space travel, make more money from it, and get to Mars. And then we have other, planets, Saturn, Jupiter, and Uranus, and then the little dwarf planet Pluto at the end. And we're learning so much about all of these parts of the solar system, including a very active field right now, which is in the research around the sun, helioscience, I believe it's called, if I have that correct. And there's a lot of work being done now to have probes go as close to the sun as possible. And we just recently had a probe enter the corona of the sun, that is just the area around the sun. So there's active research happening. And so when we talked last week about should we go to space or not, I was not giving you all the information. I just wanted to see where the discussion would go and give us a chance to talk about it philosophically. But the point is, whether you want to be going to space or not, we're going. It's happening. Now, this little video that I want to show you is just to give you more of a feeling of this idea of what it's like to start opening our minds to that light speed, large, cosmic mindset. Listen to Carl Sagan narrate this little bit, this little video from some of his work. It is really his voice. Music has been added by somebody online. I'm not sure who, but the voice is accurate and the footage is accurate, and what he's saying is accurate. And Kieran Deep online, just go to YouTube and enter Carl Sagan Pale Blue Dot and just watch that on your own. And for those of you in the Cosmos, Deep Cosmos asynchronously, do the same. And now we're going to watch it here together, okay? Here we go.
But for us, it's different. Consider again that dot.
Sorry, here we
From
go.
this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posthumous, our imagined self-importance, the delusion we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experiment. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
You know why I really like him and was so determined to watch every episode of Cosmos when it came out many, many years ago is the poetry that he brings. The music helps to strengthen that, but Neil deGrasse Tyson is very enthusiastic and knowledgeable, but he doesn't bring that sense of poetry to his writing. And this is often what happens when we start to open ourselves to space. We become kind of spiritual. We get deeper and emotional about Earth. And I'm going to be asking you to do something together in a moment that will tap into that. But let's just first remind ourselves that Carl Sagan was a visionary. In the 1960s and the 1970s, when he was doing his work at Cornell University and then began to create this television series, nobody was doing this in a public way or popular way for a mass audience. But he was trying to show people, as visionaries do, what tomorrow might look like. I think that's a nice way of trying to define for all of us as we go forwards in humanity's destiny, is that idea of what a visionary is. And it's somebody who is really trying to paint a picture for us of tomorrow, of what we're moving towards. And Carl Sagan truly believed that we were moving towards, slowly but surely, a planet-wide planetary species. That doesn't mean we're all become the same. It just means that we're all going to be sharing a story much more about who we are and where we're going. We all may have different perspectives, but we will start to understand more deeply what it means to be human. We come from Earth. That will be the story we tell if we meet any other individuals and communicate with any other form of intelligent life in our solar system or beyond, maybe an exoplanet, who knows, if we ever encounter intelligent life. The story we're going to tell is, we're from Earth. This is Earth. This is where we come from. So here's what I'd like you to do today as a little activity, okay? I'm going to ask for Hamza and the rest of you to come in here to the nucleus, okay? Because I want to get you really talking again today. But just come in for a second. And for those of you, let's fill the couches. And the reason is because you can see there what the students see right now. That's the camera there. I want the students online to see their classmates. Otherwise, it looks a little dead, the class. So can you come into the couches as best you can, like last week? And I'm going to give you something to think about together, okay? So Harris, Julian, Hamza, Masoom, and who's the gentleman next to I'll break. Great, Jacob. Yeah, come on in. Okay, and the student over here is I see a new student. I'll get my fishing rod and do my best to bring you in. Now, here's what I would like you to do together. We're going to go into threes, okay? Let's do it in threes. So, Harris, you want to come over here? And Julian, yeah, sit there. Okay. So it'll be Julian, Harris, and Noah, number two. That's number two, okay? And it will be Kiki and Tharson and Noah, number one. Do you want to just shift a little bit there? Okay, so there. Then we have the three here, and we'll try to get our friend Masoom back to life today. I know that hoodie. He has a way of, but this is what we all do. I disappear into my hoodie sometimes too. I understand. You're tired. So I don't want to put okay, Jacob, right? Yeah, Jacob, come on in, okay? And it is okay. The names again. It's not Noah. It's oh, I've got it in the tip of my tongue. It's your name again? Jack. Yeah, Jack Lemoyne, right? You want to come in here, okay? Ibrahim as well, and see, okay? And then the others back here, could you come and just sort of sit behind the couches, okay? Here, so we can kind of pack the frame a little bit. Just grab a table so we see. I'll show you what I'm shooting for, okay? Just to give you an idea. Whoops. I'm trying to fill things up. I'm trying to pack the frame. It's me, the television producer. I produce a lot of television, pack the frame with people, give it energy, okay? And now, here's the activity. These little groups of three, like last week, could you each have a discussion, but I'd like you to each pick a planet or a place that you're going to do some research about. So who would like the sun? Then I'll give you three the sun. What's that? Would I consider would I consider a star a oh, the star is a star. Yeah, the sun is a star. A star. Yeah. So so would you like the star or the planet? So what? Sorry. We can say celestial body, but the sun is our star. Okay. And I could give you a little basic astronomy just to orient for you. But in a moment, I want you to work in threes, and each group of three is going to take one body and is going to find three critical facts that are really interesting about that particular celestial body. Okay, and we're going to take all parts of the solar system. But the idea is that if we want to get real about space exploration and look at what humans are about to do and what do you want to come in? Yeah. Okay, whenever you're ready, okay? We have to be looking at what we're doing inside our solar system. Now, I'm going to just give you a little bit of context here so that you understand. Probably you know quite a bit, but some of you may not and may not want to say anything about your lack of astronomical information or knowledge about the cosmos. And I'll be honest about myself. I wasn't taught very well about science and the cosmos, and I had to learn a lot of this on my own when I was younger. But let's just orient ourselves. A solar system is a system that is guided by its star. And when we look at life off the planet right now, we are looking at first our system that revolves around the sun. But in our galaxy, the Milky Way galaxy, which is a collection of stars, there are millions of stars just in our galaxy. But then there are galaxies within the universe, and there are millions of galaxies within the universe, so it gets massive. But what Carl Sagan helped us to understand is when you start to look at our knowledge of where we really are in the universe, we have barely put our toe in the water of the ocean of the cosmos. It's a wonderful line. We are just now beginning to understand what our solar system is. That's it. Now, beyond the solar system, we have exoplanets that we're starting to see in the adjacent solar system to ours, the next part of the galaxy with its star and planets around it. But we have very little information. So really, in your lifetime, and maybe your grandchildren and great-grandchildren, we're going to be learning more about our solar system and about what's happening there and what we can do with it, okay? So that's why I really want to spend a little bit more on the solar system, all right, and on the planets, and particularly on our moon, Earth's moon, because we're starting to go back to the moon. So the guiding idea for all of you as you start to look at different parts of the solar system is we virtually know nothing about life in space. We're just we're just starting to leave the planet. And there's so much out there that we don't know. And I'm not even talking about dark matter, the things we're learning about the dark part of space and how it may be alive with particles and energy that we never thought was there. So in your little activity that you do, when you start to look at three stunning or interesting facts about whatever celestial body you will choose, first find something that's factual and real, okay? And try to find something that is going to really make us think about our reality on Earth. That if this is true about Mars, or something is true about Saturn, or something's true about Mercury, does that mean that things are going to start to change on Earth the more we learn about other things in space? And are we ready to change? Are we ready to adapt? If we go to Mars and we start to see things on Mars that we never thought possible, how are we going to deal with that information? So, here we go. Is there any group, 3, that wants a particular part of the solar system, a particular body? Noah? Jupiter? Okay, go for Jupiter. Okay, so Jupiter is going to be U3, okay? So do a little bit of research, Jupiter. Okay, well then you're going to go outside the solar system. That's fine because exo means extrasolar. That means outside of our solar system. That's what exo means. So it's a planet beyond our solar system. It's a planet in the next solar system. Fair enough. Okay, so you're good with that? You're going to go, all right, here. You take Mercury, okay? And then let's see, 3. Could you come in here? Come sit here. Come sit with these gentlemen, or let's see. And then, well, I can see it's hard. So you'll be 2, okay? Ibrahim and Jack, okay? You'll be 3, and Jacob, when you're ready, you can come here, okay? Or you can do it on your own, and then we can draw you in, however you want, okay? That's fine. So which ones? So Mercury's taken, Jupiter's taken, exoplanets taken. Which one would you like? Earth? 3 stunning facts about Earth. Okay, fair enough. Earth's part of the solar system. Fair enough. I like that. I wasn't expecting a student would take Earth. But okay, so the 3, which one? Saturn? Okay, Saturn. And then Jacob, do you want to take Mars? You go and take Mars, okay? Great. Okay, so we have everybody working now. We're going to take this up shortly. I'm going to get the heat back here. It's a little cold. Okay, great. So, and I'm now going to speak to the cosmos a little bit. Okay, so we have them working. I'll make sure the microphones are off. Okay, good. Okay, good. Okay, microphones are off, so you will not be heard. Okay, so Mercury. Or is it, are you, Jupiter? Jupiter, yeah, okay, Jupiter. Okay, good. So let me come over momentarily and see how we're doing over here. I want to, okay. So who's in the cosmos? Well, it looks like nobody. This is a completely in-person class, which is great today. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Great. Okay. Well, I'm going to go over and do something like this. I'm going to go talk to the cosmos, the distant solar system, which is the asynchronous students. I'm going to do it over here, okay? So keep going, and you'll see me on YouTube. I'm talking to the recording students, okay? Great. Okay, so everyone, let me just do this. What I want all of you to be doing as you're watching this is I want you to be thinking about the solar system as one whole thing, okay? So we're talking about the planets that we've just reviewed, and I'll just mention this again. So we're looking at Mercury and Venus and Earth and Mars, and they are the closest planets to the sun. And then as you start to get away from that, you get into planets that are not made of rock, they're made of gas. And we're looking at Jupiter, Saturn, um, uh, Neptune, Uranus, Pluto. those are the other planets at a greater distance. But all of these planets are part of our solar system. They all revolve around the sun. The sun is providing their energy. And when the planet is close to the sun, like Mercury, of course, it's very hot. And when it's distant, like Uranus or Jupiter, it's cooler. What I want you to be thinking about is which planet do you think is going to become the most important one for Earth in the coming 100 years? In other words, where might we make our most important next big thing discovery about that planet? Which planet might it be? And if you can, make sure that in your discussion post, you ask a question about that particular planet and then give the reason. Okay? So that's the way I'll be able to see if you are actually thinking about this question. Okay? So I will come back in a moment and write something for you, but I just want to check and make sure. We'll take another 5 minutes or so before we're going to get to the board and put this information down. But it looks like there's nobody right now in the Cosmos live. So it's all for those of you watching the recording out there in a very distant solar system. And I'm just going to write that question down, okay? So here's the question. Question for cosmic students. That's right. You are the cosmic students. Okay? So you are the cosmic students. On what planet in the solar system might the next big thing take place? That's the question, okay? On what planet in the solar system might the next big thing take place? Good. Oops. That. Now, for the really attentive ones among you, if you use that as your question in your discussion post, that would be great, because then I will know you've watched the recording up until this point, and then answer that question in the discussion post. Okay? Okay, good. I just did something I've never done. I talked to the cosmos while the spaceship is talking. It's a blast. Okay, let's bring this back. Okay, and we're almost there. Come on. Yep, there we go. 1 minute, and then we're going to do a little list. And Kiki will have to get back to the board, and we're going to take this up together, okay, with interesting information. And we're going to learn as much as possible about our solar system today. And speaking of which, maybe I will just run that other video. I'm trying a bunch of things today that if everything works with our system here, I can keep this totally multimedia. But this is not. So, no, don't want that. What I want is the other tab, which is this, the James Webb Space Telescope. Yeah, okay. So in 1 minute, we're going to take this up, and we'll start with a little video, and then we're going to move into our take up, and then we'll be done. So All good there. And let's see how this is sounding here. And excellent. So I don't need the Cosmos. I don't need the Cosmos at all right now. It has disappeared. We're going to get rid of them. Okay, so I think we can take this up. Are you okay to talk about Mars? Yeah, or you can even send it to the live chat if you want, okay? Just come on to the video conference, but it's better if we take it up together. But okay, so before we begin this take up together, where we're going to go around and put critical information on the board through Kiki's brain, I'd like to run another video for you that helps you to understand a bit more about how much we're learning about the um, the reality of the world beyond Earth. How many of you have heard of the James Webb Space Telescope? Okay, just a few, just a few. And it's important for you to understand that not only are we beginning to organize missions to planets, and not only have we dispatched probes back in the 1980s and even 1970s, these are actually devices that are moving through space, not quite at light speed, but pretty close. And these probes have been traveling and traveling for decades to get further and further. And some of them have even gone beyond our solar system, and they're now entering the next solar system and are sending back information to Earth about what they're seeing. But there are also telescopes that have been developed that are very powerful. And one of them is just recently introduced, called the James Webb Space Telescope. And I'd just like to show you this video that gives you an idea of just how sophisticated this piece of technology is, and what it's expected to begin telling us about very distant parts of the cosmos. Okay, so here it is. It's the James. This is an official video from NASA, so don't expect it to be critical in any way, but it's still fascinating in terms of the technology and the aspiration behind it, of what the research teams want to see.
This is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope. Equipped with the largest primary mirror ever to be flown in space, at 6.5 meters, it's more than 6 times the size of the Hubble Space Telescope primary mirror. Webb's 4 cutting-edge infrared instruments and cameras operate at super cold temperatures. Temperatures colder than the surface of Pluto. Getting this cold is done with the help of the largest sun shield ever flown. A 5-layer, tennis-court-sized sun shield that blocks heat from the sun, Earth, and moon. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Webb carries advanced technologies to tackle some of the most fundamental questions about the universe. How did the first galaxies form and evolve? Are there chemical signatures of the building blocks of life on other worlds? Is our solar system unique? Launching such a large telescope into space is an incredible engineering challenge. Fully deployed, Webb is too large to fit inside any rocket bearing. Engineers designed it to be folded, like origami, to squeeze inside the controllers on the ground deploy web remotely. Deployment is an intricate ballet. For nearly 3 weeks, controllers carefully unfold web. After this delicate dance, web's golden mirrors are precisely aligned using motors behind each hexagonal mirror segment, adjusting them to form one perfect mirror. Once the instruments are fully cooled, the exploration will begin. Web is a technological challenge like no other, born of the efforts of thousands of people across the United States, Canada, and Europe. The James Webb Space Telescope is your telescope. Use it to explore, to challenge theories, to see sights yet unseen. It's yours to unfold the beauty and mystery in the universe and our place in it.
Cool. You know, the stuff that's going on right now in engineering and science is just, accelerating. Every day there's something. So let's talk about the solar system. And Kiki, are you ready to go back and do this? And you got the pen? Yep, good. Okay, so why don't we start over here on the left with what was it again? Which planet? Mercury. So we're looking at this little guy down here, Mercury. Uh-huh. So what's interesting about Mercury? And go ahead, take a mic. You want to do it, Hamza or Masoom? Yeah, one person. Okay, yeah. Either way, okay. You can still sit there if you want. That's fine. But it's nice when you come up. If you feel like standing, yeah, you okay? Just like karaoke. So it's nice. You're close. They can hear your voice. Okay. Go ahead.
So what we decided was to choose planet Mercury.
Yes.
It's one of the smallest and fastest planet. Also on Earth, on the long days it goes Earth on like 59 days.
Yes.
On the shorter it goes like for 88 days.
Small and fast.
Yeah.
When you so small, of course, we understand. Fast as in its orbit around the sun.
Yep.
Yeah, around the sun. Okay. It's interesting. It wasn't that long ago in history that we humans thought that everything revolved around us, and that was called a geocentric worldview. We now have a heliocentric worldview. We understand that we all go around the sun. Noah? What's that? I'm not entirely sure, but it kind of makes sense. But imagine living in a world not that long ago, a few hundred years, where you thought everything revolves around us, and then you had to deal with this new information. No, 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 no. We're just a little pale blue dot, and it's the stars that matter, and they give energy to all their planets, and they're hot, and they got nuclear fusion happening inside of them, hydrogen and helium, atoms clashing together. So, Hamza, anything else about Mercury you want to tell us?
Also how the temperature of Mercury is during the day it goes up to like
Yeah.
say 800 and then it can drop to negative 290 degrees Celsius.
So during the day, when it's at its hottest, to be on Mercury would be in a temperature of 800 degrees Celsius. Yikes. What's that?
Oh, it's
And-
Fahrenheit, my bad.
800 Fahrenheit during the day. Okay, so then we have to convert that to Celsius. Does anyone want to do the Celsius conversion?
430.
430. Okay, thanks. Good. Good. 430 degrees Celsius. This is cosmic, the cosmic mind, getting used to the idea of bigger temperatures, bigger things. This is our world. It may not seem that way right now, but imagine if one day, in the not too distant future, we humans learn how to turn on and off gravity. Imagine if you leave your house and you say, well, I want to be gravity free now. And I turn gravity off and I start to float into the air and I swim through the air like a bird to my job. And then I say, okay, turn gravity on again now. And gravity pulls me back down to my. Wouldn't that be something? Well, anyways, just the thought of things that we might. What else? Anything else about Mercury? And
also one more fact that Mercury doesn't have rings and it has no satellite.
it has no satellites at all. So no moon, no.
No.
Is there anything you would say that is important about Mercury that matters to us on Earth? Or is this just like interesting information? Or would you say that having this knowledge helps us in any way on Earth?
What I would say, like it can have a weak magnetic field also in terms, yeah.
Okay.
Yeah.
And the magnetic field? Magnetic field is very important in understanding that. I can actually give you my facts may not be entirely correct, but it's a positive story nonetheless. And I just want to mention it quickly because I hope today will be a positive class. Do you know that it wasn't that long ago there was a thing called a hole in the ozone layer? And the ozone layer, I'm not sure if that's connected to our magnetic field exactly. But just to give you a positive idea of how humans can solve problems. In the 1980s, the 1990s, we discovered that the refrigerants and the things that we spray from aerosols and air conditioners were putting PCPs, something fluorocarbons, into the atmosphere, and that had brought a hole in the ozone layer that protects us, the ozone, from the sun's heat. I may be wrong about that, but let me just continue, okay? We were concerned, so concerned about the hole in the ozone layer and how this may destabilize the planet's climate in the same way we have been about climate change with fossil fuels, that the world actually came together and the leaders came together and banned chlorofluorocarbons or controlled them to the extent that we now can see that the ozone hole is much, much smaller and is no longer a threat to our environment. But the remarkable thing about that solution at that time was the British Prime Minister, Margaret Thatcher, and the American President, Ronald Reagan, they both liked science. They both understood the importance of science. Margaret Thatcher, the British Prime Minister at the time, she had studied science in university. Ronald Reagan, he understood science too in his limited way, and they weren't afraid of it. We are living at a time where there's a lot of fear over science and what it's telling us. And there's a lot of conspiracy talk about what is really true. But those two leaders believed in real science, not pseudoscience, and they saw the connection between PCBs and the ozone layer, and they helped the rest of the world to eliminate this problem. Isn't that a good story to some extent that we are capable of solving our environmental problems if we're not so stupid? Well, that's not a fair thing to say. If we're not so slow to understanding science. Yes. Anything else, Hamza, you want to?
That's all.
You want to say? Okay, thanks. Just want to add that, there's the magnetic field. I can say one thing that can help you is that at the core of the Earth is a huge ball of iron, hundreds of kilometers in diameter. And that iron, because it's there, and then it produces sort of liquid iron around the core iron, that iron brings a magnetic field around the circumference of the Earth. And that magnetic field protects us from the sun's heat. If that magnetic field was not there, we would be fried. Mars, I believe, has no magnetic field or very little. And it once, we believe it may once have had a magnetic field, and there may have once been life on Mars. We're starting to wonder about this. At any rate, the ozone, the hole in the ozone layer and the magnetic field, it may have been there was a hole in the magnetic field or something, but I'm not entirely sure. At any rate, we've passed that problem. And the magnetic field, though, is an important thing about Mercury and other planets, too. Whether they have one or they don't, that's critical. Okay, great. So let's move on. All right, so that's Mercury. Who's next over here? Jack and Ibrahim. And do you want to add anything about Mercury? Pass the microphone around and we'll do it that way.
Well, I see that for the core,
Yes.
it's considered to be the largest metallic core.
Largest metallic core.
Yeah.
It's not iron, is it? I'm not sure. Is it a large iron core too in Mercury's core? Okay.
And the second densest planet. So.
Second, it may be that because it has that large iron core, provides a durable magnetic field. That's why it hasn't just been completely fried. I'm theorizing here. You know, I don't know exactly, but that's a good fact about its connection to Earth. Okay, let's keep Ibrahim, Jack. You did Earth, so tell us about Earth. Go ahead.
About like 50-80% of life lives in the ocean, and that there's approximately like 700 to 1 million animals, excluding microorganisms.
Okay.
And we've only discovered like I think less than a third of those species.
Yeah, there's still a lot, and a lot of our discoveries have to do with creatures underwater. There's a lot that we don't know. Do you know who is an interesting person, a visionary even to think about when it comes to the world underwater is James Cameron, the Canadian director of Titanic and Avatar and Terminator. Do you know he just comes from a little town near Niagara Falls? And I know that because my mother was in a senior's home in that town. The name escapes me right now. I remember the name of the senior's home, Willoughby, and it's just very close to Niagara Falls. The name is escaping me. And every time I would drive back from visiting her on the weekends, I'd see a little plaque in this town for James Cameron when he grew up there before he went to Hollywood and did all of his big work. But he's been doing a lot of research around the world underwater. I think it was partly inspired by Titanic and what he did with Titanic and the movie, and is supporting much more rigorous research to understand life underwater. What else do you have about Earth? So if you take that bit of information you gave us, what would you say is the most important fact that we need to think about around Earth? Like, what does that information mean in terms of species and creatures and diversity? What does that really, what's the takeaway for us about Earth? We can discover more, and we have life. It's called the biosphere. Everything inside this biosphere is living. Only Earth has this, as far as we know, the biosphere. It's everything inside that little ribbon that goes around the planet is where it is chemically alive. And the chemical part of it is really important. It's alive here. And you may never have thought about it in these ways, but people like Carl Sagan do. When you realize that everything is alive here and everything that we're talking about elsewhere is not, we start to see life as a bit of a miracle. And you may, if you think about this today and you walk out of this class with what we did, you may start to realize that you just being alive and being conscious as you are and having that privilege on Earth is truly a privilege. Don't waste it. Don't waste your life. Now, it's easy for me to say at 63 almost. For you, you probably don't think of these things, but if you did earlier in your life, I think you might accomplish more, personally. But anyways, Noah? Go ahead. Yeah. One of the rarest, which is wood. Tell us about wood. Well, wood comes from trees, which are living things. Huh. And wood would only come from something that has DNA and has life in it. I like that. Trees. Well, they're trees. Trees, wood, and it's true. Beautiful. Yeah. Wood. Absolutely. Very good point. Wood. Wood is something else. It's a living thing. It has exactly DNA in it. It reproduces and it grows and it responds to stimuli just like we do. The 4 elements of life, which is metabolism, reproduction, capacity to respond to stimuli, and growth. We have that, and trees have that. Earth has that. Nobody else does. Nice. That we know of, okay? That we know. Let's keep going. Jack, do you want to try with Mars? A little bit? Not Jack. Jacob. Sorry. Jacob? Mars. One thing? Okay. You think about it, okay? And then if then you can always bring it to the class, okay? Just raise your hand when you're ready. All right? Perfect. Okay. Jack, do you want to add anything about Earth?
So the distance between Earth and the Sun is
Yes.
an AU, like an astronomical unit.
Yes.
And so that's the like the unit we use to measure every other planet's distance.
It's called an astronomical unit.
Yes.
Okay, well, let's try and understand this a little bit more because that's pretty abstract and maybe we don't see. So, what exactly is an astronomical unit? Like, how would we explain that in simple terms? Think about it, okay? Or even better, in kilometers, what's the distance between Earth and the Sun? So if we take, here's Earth, here's the Sun, what are we talking about? How many kilometers?
150 million.
150 million kilometers. Exactly. That's my understanding too. Excellent, Jack. 150 million kilometers. 150 million kilometers. Well, guess what? Just in the last 2 years, one of our probes that left Earth some years ago, I can't tell you exactly when, it had been traveling and traveling for years at a very high speed, but not light speed. We don't yet have anything close, any kind of craft that we have built that can go at 250,000 kilometers per second. But wouldn't it be something if we did? Not really. Why not really? Which? But nonetheless, we might still be able to reach places that we haven't, including some comets that we might be able to see more clearly in the solar system. But we still have a very, I think what Noah is saying in a way is we still have a very, very long way to go before we can really start to get further out into space. And maybe some of you will enter a career in engineering or computer science or some field that will help us go further and explore more. Kiki? Give her a microphone. Can we get Kiki a microphone? Yes. Go ahead. Please make your point.
So I think what we need to actually start doing is learning how to reproduce in space and educate generations that we've reproduced on what their mission is, you know?
And what would be the advantage of reproducing in space as opposed to reproducing here and then going into space? Alien babies.
Yes, alien babies. But also, future generations could slowly but surely make their way to other celestial bodies.
Maybe.
It would only take us about they estimate about 3 months to get to Mars, but we could realistically go further. There is the TRAPPIST-1 system, I think about 39 light years away from us. And in fairness, that would be probably tens of thousands of years of travel time for humans to try and get there. But
yes.
we would need to be reproducing on a spaceship for a very long time to be able to get there.
Okay, but here's my question. If you look right now at the solar system, and I'm just trying to do this properly, and I'm having a little bit, I'll just zoom out a little bit and see. Good. Okay. So there we go. You see the sun. The sun is much, much larger than any of the planets. I believe its size is about 1,000 times larger than Earth in terms of its size. And at its core, its heat is something like 15 million degrees Celsius. A million Earths? Okay, it may be. It may be. It's much, much larger. So the planets beyond Earth are not, there's no rock. Where would we land? If we were to start to, try and organize missions, all of these planets, Mercury, Venus, Earth, and Mars, there's the third rock from the sun, Earth, and then you're all rock here. Where would we land? In a gassy planet. Yeah. So it would be a moon or one of the satellites that has a hard surface, but we wouldn't actually be able to get in there. But we are, with the probes that left some back 30 years ago, we have now reached the corona of the sun right in here. It's a very active field, helioscience, where we're starting to, this device that is there was built to withstand the heat of the sun that close up. So it's not burning up. There is actually a craft right now that is orbiting around the sun and gathering information, and it is in the corona of the sun, which is outside, but in its field. That's how close we are now to the sun, and we're gaining data more and more about the sun and what it contains. Sorry, does somebody want to say something here? Noah? Yeah, go ahead.
So I wanted to bring back up the topic of reproduction in space.
Yes.
It would actually be really important because of the fact that most creatures adapt to their environments over time, over very large periods of time.
Yes.
So things like gravity, people here wouldn't be able to sometimes handle or work the same way as somebody that might have grown up on a different planet like the moon or
That's right.
Mars.
That's right. Do you know that when astronauts come back from space, Chris Hadfield or any other astronaut, or Jeremy Hansen, who's about to go into space, the Canadian, as part of the moon mission in 2026, they have to do a lot of physical training to prepare themselves for a remarkable transition. It's not so much that when they go into space, they have to adapt to the gravity-free environment. There are ways to maintain the body and its physiology by exercising in space. So astronauts, when they're on the space station, will be on their stationary bicycle, 2 hours, 2.5 hours a day to make sure that they maintain their metabolism. The problem is when they come back. And what astronauts have said that is so fascinating is that it's hard for them to adjust now to the weight of being back on Earth. They've been used to being without gravity, and now they're being pulled down, and they can kind of get depressed. Isn't that fascinating to have to adjust, so humans are doing that already, Noah, the astronauts, in having to adjust to specifically coming back from space, going from gravity-free to full-on gravity, and that requires a new kind of body that has to be strong, and psychologically speaking, the astronauts have to be prepared to deal with the destabilization to their system that can also precipitate mental health problems. So the human has to be really, really developed to be able to go into space. Will we be able to handle that psychologically and physically? What will we have to do to adjust? These are big questions, but you're right on it. These are huge questions for humanity. If we're going to go into space properly, we better be able to handle it psychologically and physically. Noah? Yes, that's the one. That's not Matt Damon. That's the Interstellar is the other between. I get them all mixed up.
The one where they go to the exoplanet solar system that orbits the black hole.
You know what? I don't think I've seen that one.
Really?
Or maybe I have and I just forgot. But I love the music from it.
Yeah.
So I'm sure I've seen it. But okay. Anyways, go ahead. Interstellar. Yeah.
So
yeah,
they use a method in there to get artificial gravity with the ship that they use to travel, which is called the Endurance.
Yes.
If you were to rotate a ship at a certain revolution speed, you could probably mimic that of Earth's gravity. Would the effects from space be nullified if you were to create artificial gravity on a spaceship?
No. I don't know. Well, give Ibrahim a mic, or here I'll give him. Go ahead. You hold that one, Jay. Yeah, and I'll give. Go ahead. Why wouldn't it be? Good.
Because basically our muscles are working against the gravity. That's how we're able to.
The normal force.
Yeah. But if we go out of space, there's no gravity. Our muscles not working at anything, so it doesn't adapt or contract. But if we're able to simulate that, it would work as the same as gravity.
I guess you could look at it as more of manipulating centrifugal force as opposed to actually creating gravity.
But I'm pretty sure it would create the exact same results.
Would it?
I'm pretty sure.
Okay.
Well, we need to be thinking about these things. I think Noah, number one, has helped us to understand we have to think about the effect on the human. I'm going to start to conclude, okay, because we only have just a few minutes left. We can review next week the others here, okay? I'll make sure. We've only done part of the solar system today, but I want to make sure you get out of here on time, and I also have just a couple of other things I want to address in terms of the second assignment and the final assignment too. So does anybody have any questions at this point as we wrap up at least this part about understanding our solar system better, a little bit better today, getting a sense, just a sense of what some of the missions are that we're starting to take into space, and the importance of understanding solar system research. This is going to be relevant to your lives and your children's lives, what we discover and what we might even colonize. We may even start to create the first human colony off the planet on the moon. So, second assignment is due November the 30th. That's this coming Sunday. Remember, you have the two choices. You can do the DC Talks event. Pick one class of the 11 that we've done this semester. Don't pick another class in another course that you're taking. You choose. The final assignment sheet has been posted. I wanted to let you know everything is now there for you, including examples of students' work. That assignment, which is your big work of the semester, is due on Wednesday, December the 10th. Okay? So try to familiarize yourself with that assignment sheet in the next 2 or 3 days. It's there for you. And I'm hoping that you will do something for that assignment, because that's a big one that you'll be really proud of. I had a student in another class today come to me and said she's already ready to do a video. I've had students do short documentaries. I've had students do amazing presentations. Try to think of that final assignment. Yes, you want the high mark. Of course you do. But even more, try to think of it as something that you're going to be really proud of, that you will think, at Durham College, in my humanities destiny class, I did a final assignment where I really thought deeply about something. And if you choose an assignment like a life plan, which you could do for the final assignment, you might end up laying out for yourself a blueprint for your own personal future that could be very helpful for you, a kind of a roadmap of what you want to do with your future. I'm going to give you that chance. So just try and not leave it to the last minute, and try and think of it as something that's going to help you develop as a human being, not just get a great mark. I know you have a lot on your plate. I know you have many other courses. I know that this course may be less important than your other courses. I get that. But at the same time, I'm not sure you have any other course that gives you the chance to really think about you as a human being, your future, and the future of the human race. And you may not have another chance to think about these things in the next few years, if at all. So take advantage of this opportunity, okay? Great. Kiki, thanks for the notes. Just leave them up there. Cosmos, well, bye-bye, empty cosmos. I like seeing humans, not just cosmic creatures out there. See you next week, everybody. Okay, excellent. Okay, thank you. And let's, okay, I'm going to stop. Well, I have very little here to post, but I'll do that. I'll do that. I will do this. I'll do this.